So Copernicus wasn't the first person to kind of break out of the Ptolemaic model or the geocentric model. But he kind of, from what I've read historically, he was careful how he stepped into this. The idea that the Earth is so very important and the heavens are static above the Earth and the heavens or go around the Earth in a circle, that was very important theologically speaking to, I would say, many religions. I know Christianity that was quite important. But so Copernicus brought up again, I would say, and published the fact that no, it's actually the sun. The Earth goes around the sun. Okay, and actually, you can see on this slide that he actually estimated the distance between the Earth and the sun, and we call that 1 astronomical unit. So that's pretty cool. But the thing about Copernicus was he still did not get away from, and I don't blame him, the fact, orbits seem like they should be circular. And as the planets orbit the sun, it's not a circle. And because of that, he could not ultimately predict where the planets would be. So notice from this slide, you can tell that he honestly saw those wanderers that we were trying to explain why they went back, those Mars things going in the direct motion, the retrograde and direct. He saw those as planets also orbiting the same star or sun as the Earth. Okay. So when Copernicus said, let's step outside of this whole geocentric model and let's put the sun at the center. By the way, I don't have this on a slide, but I'm going to try to spell it out here. It's called heliocentric. Geocentric is that the Earth is the center of everything and everything orbits the Earth. And heliocentric, Helio, heliocentric model, okay, is where the sun's at the center, and the Earth orbits the sun and the other planets orbits the sun. So here's how we can explain retrograde motion by putting the sun at the center of the solar system, and the planets orbit the sun. And I'm going to show you a slide coming up, but I'll kind of try to describe my thoughts on this, how this works. It's in so many words on the slide. So basically, I tell people, if you are driving a car and you are in the left lane, okay, because you're driving faster than the person in the right lane. So for a while, and then see, you guys, if you're a driver, you know what this feels like. It's kind of a sensation thing. Let's go ahead and put trees in the background. Okay, you're out in the country, set of trees, like they are just identical trees going on and on and on. So as you approach the vehicle, that vehicle looks like it's moving forward against the background trees, okay, because you're both moving forward against the background trees. As you go to pass the vehicle, because you're going faster, it looks for just a little while like that vehicle is going backwards against those background trees, just a little while as you overcome the vehicle that's going slower in the right-hand lane. And then as you pass it, then as you look back, or somebody looks back at that tree, again, it looks like that, or looks back at that vehicle against the background stars or trees that you just passed. Again, it looks like it's going forward. So I hope this helps. And here's a slide to kind of do as much. So the blue is the Earth, and red there is Mars. One of the things that we know is that just like the left lane for traffic, if there's multiple lanes, the left lane goes faster. So also, the closer you are to the sun, you're going to go faster in your orbit. So you're going to see the blue planet, us, moving faster from position 1 to 2 to 3 to 4 to 5 to 6 to 7. So those are different positions. Okay, so for instance, so in this case, position 1, we are kind of coming up on Mars. And so you see Mars is in the constellation Gemini, okay? It has direct motion, okay? We're catching up to Mars, and now Mars looks like it's in Cancer, position 2. Position 3, we're still trying to catch up to Mars, and Mars, you can see, has gone a little bit farther that way, okay? Now, position 4, can you see where Actually, we are straight connected, or not connected, we have caught up with Mars, and now Mars looks like it's going backwards, okay? We're both going this way around the sun, but it looks like it's kind of pulling back, okay? We overcome it, okay, at position 5, and it still looks like it's kind of going back, and then position 6 again and 7 again, we're sufficiently far from it, and it looks like it's going direct motion again, okay? So that is, oops, let me go back. Just to kind of make sure we're on the same path here, this is direct motion, okay, and this is retrograde right here, the 3, 4, 5, backward motion.